Hey everyone, I'm Dr. Surjit Singh. In this video on Python via examples, I am introducing Math Library. Let us begin. In this session, we will discuss constant pi defined in Math Library and some functions including factorial, greatest common divisor, integer, round, floor, and ceil that are also present in it. We will also discuss float, square root, sine, log, and exp functions. Further, we will learn about runtime input of data and truncation error. Python has many libraries which have a long list of functions. Math library is the most important of them all. We will discuss some of its library functions. Factorial is one of the most commonly used functions. We can import it from the math library by the statement given here. We can now use it anywhere in this program. Factorial 4 returns the product of 1, 2, 3, and 4. GCD is a simple function that is also present in math library. It gives the greatest common divisor of its parameters. There are 4 ways to convert a floating point number to an integer. Out of these 4, 2 are available in Python, but we have to import floor and ceil from the math library. Int function simply removes the decimal point. Note that the print statement is very long and we have separated it into 2 lines. We press the enter key in the middle to break a line into 2. In the round function, a floating point number is rounded to the nearest integer. Floor function gives the nearest integer that is less than or equal to x, while the ceiling function gives the nearest integer that is greater than or equal to x. Note that if x is 0, all the 4 functions return 0. If the second parameter is given in the round function, it represents the number of decimal digits where rounding is carried out. In addition to functions, math library also has constants that are commonly required in mathematics. Pi is one of them. We know that area of a circle is pi r squared and pi is approximately 22 by 7, whereas we also know that 355 by 113 is its better approximation. But we prefer to import the best value of pi as defined in the math library of Python. We will use this value in our program. For r is equal to 5.3, we find the area of the circle and print it. We may like to know the value of pi used here and compare it with 22 by 7, which is correct only up to 2 decimal places. We can provide the radius of the circle at runtime, for which we have the input function. String argument of the input function becomes prompt for input. Python prints it on the output area and waits indefinitely till we key in the value of radius on the keyboard and press return. Input goes to memory as a string, so we use float function to convert it to a number and save it in the variable r. Rest of the program runs in the same way. We can rerun it again and again and enter different values of r. Square root is another commonly used function. Programming to find the square root of a number is highly complicated, so it is essential to make it a library function. Let us use it to find the square root of 2. If we write this program, we will find a red line below square root, which indicates that Python does not understand this word. This is so because we have forgotten to include math library this time. Bring the cursor on square root and wait. Python interpreter will suggest the remedy. Select quick fix that will give link to add square root from math library. Just click on it. Python will import the square root function for us and the red line goes. This is the power of Python, that it can by itself resolve errors and omissions. Running the program gives this output. That is so easy. Change number to 3 to get this output. Actually, the result is an irrational number for which decimal digits are endless. However, we get the result up to 16 decimal digits. Python truncates the rest. However, the truncated part is negligible for most of the problems. Argument of square root can be any arithmetic expression. If the argument produces a negative number, square root will give a runtime error because the result is not a real number. This program gives hypotenuse of the right-angled triangle. It uses the square root function. We know that long Python statements can be written in 2 or more lines. Log is another commonly used function. Three bases for log available in Python are 2, e, and 10. We import here log to the base 10. Let us find log of 50. We get this as the answer. We can format the output and limit the result to 3 decimal places. This output has far better readability. .3f format means we use minimum space to show result to 3 decimal digits. We know that for floating point numbers, Python truncates result after 16 significant digits. This program finds height of this triangle whose hypotenuse is 8 and the angle is 30 degrees. We have the trigonometric function sine in the math library for this purpose, but it takes angle in radians. So we multiply angle with pi by 180 and then take its sine. We expect the result to be 4, but Python gives slightly less value because floating point numbers cannot go beyond 16th significant place of decimal. In this case, the error is 4 point something into 10 to power minus 16. Surely this is negligible. Such truncation errors are common in floating point calculations, but they are almost always negligible. Scientists tell us that 1 gram of hydrogen has 6.023 into 10 to power 23 atoms. This large number is known as Avogadro's number. Reciprocal of this is the weight of one atom of hydrogen. We divide it further by 1000 to get weight in kilograms. As our Avogadro number is correct to 4 significant digits, the weight of the hydrogen atom is also correct to the same accuracy and the remaining digits are meaningless. Truncation error is much less than this, so there is nothing to worry about. Largest floating point number possible in Python is 1.797 into 10 to power 308. We can print it. If we double it, the result is shown as infinity. If we double it again, it remains infinity. Negative of this is minus infinity. Smallest floating point number possible in Python is 5 into 10 to power minus 324. If we divide it by 2, it becomes 0. Last library function that we will discuss here is exp function. We know that e is 2.718 and its square is 7.389. Pi, square root and sine are required by all. However, for mathematicians, importance of e is much more than that of pi. Before ending, I would like to discuss the program to find factorial of a number. Like sum is equal to 0 before any summation, we write product is equal to 1 for factorial. The range function here gives the values 1 to n to I. We multiply these values to product and it becomes factorial n. If we make checks for validity of n before starting the loop, this becomes the complete factorial function. I would also like to discuss the Newton-Raphson method for finding square root of a number. In this, we have to assume a trial root in the beginning. For n is equal to 16, we assume here 1 as the trial square root. The average of root and n by root is a better square root of n. 8.5 is closer to the square root of 16 than 1. So in the next iteration, we take 8.5 as the trial square root. This gives value 5.19, which is the trial square root in the next iteration. The convergence of this method is very fast, and in 5 iterations we get nearly the exact square root of 16. Number of iterations can be decided by comparing the latest two values of the output. They depend largely upon number n and the initial trial value of the root. We must ensure in the beginning that n is not negative, as otherwise the convergence is never achieved. N is equal to 0 may also create a problem. It is better to use the library functions as they are written by experts, so their methods are most efficient and have employed proper checks on the parameters of the function. In this session, we discussed math library for constant pi and functions factorial, GCD, integer, round, floor, ceiling, float, and square root, sine, log, and exp functions. We also discussed truncation errors. In the end, we wrote our own versions of factorial and square root programs. Hope you enjoyed the video. Please feel free to ask for further clarifications on my email address given below. I'm looking forward to your comments. Stay tuned for more.